do Elon Musk, the electron volt, and chemistry have in common? Well, we conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes. We returned from the hyperbolic vortex chamber a while back. Yes, 2 weeks too late. But to address the initial stuff and things we were saying, basically, we went back out to the great state of Utah. We visited the physics monastery for the longest period yet. It was quite a ride, literally in some cases. But one of the main focuses we had was chemistry. Well, actually, chemistry and cosmology, now that I think about it. So we had a number of talks. We had some new faces there, some folks that I hadn't yet to see before. You know, the pictures and the little screenshot and everything there. But, so what am I talking about? Well, since we're talking about chemistry, the electron volt is a very important thing. And at least from the model of the minimal arena, or to attribute it to Jen, the HF8 model, yeah, we're able to do and get prescriptions for the 44 constants of nature, basically from the realm quantum and everything. And to chemistry, my initial thought was, well, we just take what we get and then we add and we multiply and we do all the standard things. Oh, no, my friends. It was far cooler than that. Because a lot of stuff in chemistry, it's apparently chemistry and physics, they actually have different units. That was one of the things that I was kind of interested in. Even on Wolfram Alpha, you're looking, it's like, all right, so it's like, oh, you get like hydrogen and everything. It's like, well, we have a thing in physics, we have a thing in chemistry. Why? Because our calculations are a little bit. We need to unite them somehow. How do we unite them? The AMU, the atomic mass unit. It's basically it's if you take the mass of the proton and basically you take carbon 12 and you divide by 12. So like, all right, there's a bunch of things. Here's something that's pretty stable and everything. So yeah, so we can totally just yeah, we'll do this. To actually derive that was kind of hard. It was part of my homework. I started my homework and I got really confused at it and figuring it out. Because basically what you need to do is you set up the boundary conditions. And I will actually put out a video. I think we'll do the speed of light or something. How to actually do these little things where it's like, oh, let's calculate a constant of nature. Let's go through the prescription there. Because it can be tough. Because sometimes you're searching for something. Maybe you get a different answer. Maybe your parameterization space is a little different. That showed me some tricks. So what we're going to do is basically in chemistry, they measure things by electron volts. It's like, okay, we have mass and everything that we had derived before. It's like, all right, we have geometric derivations for the Planck mass. I do need to go through those base 5 equations because at this point, now I actually know what the heck I'm doing. And I'm not as intimidated. I'll still probably get them wrong and you do little redos, but we have a geometric derivation for that. And you just add all those together and actually shout out to Shiloh and Anastasia from the Demystify Psi podcast. They had a gentleman on. Oh God, I forget his name. It's no something. I don't know. I need to reach out to him, but apparently he's been working on quantized inertia. It's like you don't necessarily even need dark matter per se, because one of the other things with Wolfram Alpha, you notice it's like, all right, you start doing a solid or something. It's like moment of inertia. Seems to be some big matrix and it's got tensors and stuff in it. I'm like, what is this thing? Apparently, it's like Newton's first law. It's like, all right, a force will tend to just do its thing unless it's acted upon. Basically, something to accelerate. And once you hit that whole like unradiation thing and everything. Oh, basically you're outrunning some of the photons of your past light cone or something like that. As long as you're accelerating, because if you accelerate really fast, okay, you can have the mass. But if you accelerate at a slightly lower rate, but as long as you're still accelerating, allegedly there's a sweet spot. If there's a sweet spot there, it's like, wait a second. Yeah, yeah. Apparently they'll just go over it quite easily, and you don't need to see. It basically explains the whole like rotations and everything. It's like we don't see all this extra dark matter. It's like, well, what if it's just working well? It's almost like it's working as intended, and it also kind of like threw us off for a while. Still could be wrong, personally. My opinion, again, just on my part. Personally, I think our realm persistence is older than 14 billion years. If that was the case, it's probably going to be some more black holes, maybe even potentially some black dwarfs per se. Basically, a whole bunch of stuff that our instruments aren't really good at seeing that well, especially if something's just kind of burning out and it's really dark. Also, probably some more neutrinos. Um, I'm just saying. I'm just saying. When folks are like, we're looking for these axions, but in a couple of years we're going to enter the neutrino range, and we'll just be blinded by all these neutrinos. So what you're saying is, in your search for dark matter, you're afraid that in a couple of years, all you're going to see is dark matter. Not the dark matter you're looking for, or is it? But with that, yes, we went through chemistry, but basically things are measured in an electron volt. Yes, yes. 3-minute side tangent there. I know. What else is new? But as far as that goes, it's like, all right, you just keep on using the same prescription. Keep on suiting primary action. All right. Your boundary condition, your dimensional ingredients, time, space, mass, temperature, charge. Okay. Now the thing is with the boundaries, the mass boundary, sometimes it's like maybe using the Planck mass, maybe using the mass of the electron. Hint, the mass of the electron is used for a lot of them. Sometimes it's divided by it, sometimes it's the. It's funny how you use a base found elementary particle. Actually, that's how that kind of went through the derivation to calculate the proton and neutron mass. Once you get the electron, it's basically like 2 volumes of the hyperbolic figure 8 knot is within, I believe, the primary action. Maybe the boundary condition. I believe it's the primary action, aka for Giesking constants or manifolds, how they work together. Just saying. But we've entered the realm where certain things appear to be greater than whatever the Ge raised to the 4th is. Because that's basically just within the quantum realm, basically do it up to 4 times. Now, whether it's Ge1, basically the Sommerfeld constant you square, it's the fine structure constant, or the other 3 answers to the hyperbolic vortex equation, which technically are the three, yes, as I hope for, the 3 other fine structure constants. Who knew? I do need to redo that other video and actually update it and maybe some. Yeah, I do need to submit it to that complexity journal that Professor Wolfram has, but we'll see. We'll see. But yeah, we kept using that, and we found some pretty cool stuff. Now again, I'm not gonna say it's right, but it actually happens to at least not done. I think we actually have like 80 something more to go. Because basically the last time I had gone down there, I had let Thad know. And so it's like, I'm not getting the right numbers and everything. So we go to NIST.gov, you go through there and everything. You're looking through the numbers and they're like, these have been updated. Why? Because the scientific system, SI, the SI units, had been overhauled back, like 2019. I think they actually defined the mass of a kilogram. We're not just using the whole whatever, the brick of platinum or whatever we had that's sitting in like, I don't know, like Switzerland, Sweden, France, wherever. A couple of those things. It's like, all right, let's just define by the Planck mass and we'll be done with it. Also trying to get a lot of those other different constants in nature to kind of harmonize. I'm sitting back, I'm like, well, we've been playing around this for a while, and we didn't know until we actually went back and checked. I'm like, I I hope all the folks at science know. I mean, they should know. I mean, it's not like we're using old numbers, and even some of the numbers, maybe you disagree with it. They're trying to make it coherent the best they can, because that's the whole point of a coherent set of units, right? Because once you have a coherent set of units and you have your equations of F equals ma, force equals mass times acceleration, power equals acceleration times distance, and then energy equals power divided by time. If you can set up a parameterization like that, yeah, basically whatever you're using without a fundamental additional constant that's not one in front of it, basically the rest of physics essentially ends up being true. At least that's what the Wikipedia article says. I'm just saying. I'm just saying. But yeah, the interesting thing is you're going through and you're calculating electron volts, and you start to see some more patterns as well. It's starting to look like maybe there's an imaginary continent involving the infinite power of I. I'll share them once Dad actually comes out with his videos and does those. I may have a little teaser in the meantime that I actually worked on. That basically had set it up as a layup, and I searched very, very for a while. But welcome, Snacks. I saw you getting your swell on. Level up, my friend. But the thing is, it's like there does seem to be a pattern emerging. Now, again, I am totally biased on this. Do I want it to be true? Of course I do. But we need to address our biases. That's important, I hear. But, okay. So we start, and you start seeing the pattern that tends to emerge, and it's like, it's very pretty. Apparently, there's a whole lot of e, which is the base of natural logarithms, and then raised to the Euler-Maccheroni constant, or maybe negative. I occasionally pronounce it as the Euler-Macaroni constant, because who doesn't like mac and cheese? Apologies to my lactose intolerant brethren out there. I understand milk makes me a wee bit gassy, but my thing is with this, I'm like, okay, I did not expect this whole system to work this well. It's like, it seems to be continuing to work. Now, again, maybe that's just a combinatorial thing. Maybe it means absolutely nothing. But as a noob dude on the internet, not a professionally trained physicist, I start looking at some of these things, and the more and more you play around, the more and more time you spend, the more and more you look at, the more practice you get, the more and more you learn about science, you're like, I can actually start to tell a story about this. Is the story right? I don't know. It's going to have to end up touching a lot of observations. But if we can actually start touching chemistry, because I think we got to, was it the helion is I think that's a helium atom. The tritium I think is tritium. The deuterium is basically, what is it, hydrogen plus a neutron and everything. I think that ended up solving all of those. And so once you get to that point, it's like, it does that mean we just have the rest of the periodic table? And then the other thing, a lot of stuff is like this divided by this. But hey, welcome, Fractal. Yes. The chemistry angle is fascinating. Yes, you're right, deuterium. But my big thing is, I didn't really expect that to work. I just figured we were just going to take the stuff that was already up on the previous poster that has been in some of the videos and everything. We're just going to add that stuff together. But the new poster, once it gets printed out, it within the chemistry section, it literally has a constant of nature kilogram, meter, second. I think. Oh, is it? Does it have Kelvin? Does it have the actual charge? Because we already had the Planck charge and the charge of the electron there, but it seems to be breaking down and just simplifying. And again, I'm sorry. I'll go over pretty much everything once Thad releases his video and everything. I don't want to jump the gun on that just because it's like it's not publicly out there yet. So it's like, we'll let the maestro do his thing, and then we'll go over it and everything. And you start to see it's like, okay, well, aren't these human created units in some way? But we chose the atomic mass unit. Why? Well, we're trying to be coherent. It's supposed to be the bridge between physics and chemistry. Here's an atomic unit that we can use. And when you take that AMU and you multiply it to like 294, which is I think the maximum form of element 118 oganesson, that they've actually been able to detect a couple of atoms from, it seems to hold. I did have some crazy equation and stuff before they got really, really close, and I'm like, But then again, that was just me playing around. It actually had E in it. I think it was raised to E to the base logarithm. That's another story. But what we're going to be doing is that should come up with that video probably within the week. So we'll go over that. I have an interesting thing from general relativity that I've kind of been working on. So yeah, no, oh my God, the charge of the quarks. I didn't think about it till actually one of the other physics monastery founders was talking, and he was like going in. He's attempting to basically program using physics. You're like, what? Well, we're already doing that. Rather than doing what we've been doing and whatever, 64-bit, whatever we are, the parameters we have. For a long time I've wondered. I'm like, why is it I've been on the internet for far too long? And over the past decade or so, internet speeds have gone up, computing power has gone up, and everything. And I'll go to like a lot of websites, like not even like a YouTube. Actually, YouTube's pretty good, but just a normal website. I'm like, it really doesn't. The internet doesn't really seem that much faster. Why is that? Apparently, we've been building upon like old things and everything. It's like, oh, we've just kind of mitigated with computing power and everything. It's like, well, what if we literally started from scratch and we tried to like literally start to compile everything unto itself and then program using, well, what are we going to assume is probably the most perfect thing that we could kind of imagine? How about our universe? What are the rules of the universe? I don't know. You go into this, and then one of the things within the programming stack that he was going through, I'm like, all right. So it's like, oh, you get three identities, you get three colors, then you got two states. He's going back and forth. I'm like, this seems to make a lot of sense. Wait a second. Wasn't the simplest Turing machine like a three-colored, two-state Turing machine that Professor Wolfram proposed in his big book? Oh, God, I almost fall over. Ugh. New kind of science, which I still need to finish. I listened to his full like lecture course on it and everything, so I feel like I learned. And every time I open it up, I just find it's like, wait a second. Of all the possible cellular automata, I think it through dimensions, it's like they tend to trend towards 4 styles. That's fascinating. That's per unit of computation. Now, again, I'm not saying that the simplest Turing machine and perhaps our simplest universe, let's say, may actually have a computational equivalence. Okay, I totally made that claim before. It's looking more and more likely there might be something going on there. Maybe I'll ask the professor in one of his Q&As coming up or something. Be like, is there anything going on? Have you ever inquired about like the like quantum chromodynamics, like the quarks, the states of quarks? What was it? The 3 known quarks to our knowledge, or it's 3 primary quarks that we have. No, we have 2. No, we have different. Never mind. But I think it's just fascinating. But yeah, as far as the stuff coming up, yeah, there was a little thing on general relativity we kind of worked on. I did a very copious search. I found some answers. First answer that I was really excited about actually didn't give us the greatest answer. Would tell a great story. The one that caught Thad's eye that I showed him. I'm like, okay. When I actually looked into it, I'm like, this might actually explain a lot. Why does our realm of persistence appear to be random? Even if Professor Einstein's like, yeah, it doesn't play dice. What's the closest you could get to literally being random with maintaining beauty and not necessarily feeling fully random? But I don't know. I guess we're going to have to see. But I've rambled on for 20 minutes. So maybe we'll do an AMA or something in the future there. Maybe actually schedule some of these things, maybe have some folks on. But hey, thank you all for watching. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there. But peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.